Hello students, welcome back to my YouTube channel Mathematical Lens by Ganitha. In this video, we are going to continue with chapter number 8, playing with constructions of grade 6 mathematics of the new NCERT textbook Ganitha Prakash. And we are going to learn more about squares and rectangles and their construction in this video. So now let us look at some basic figures here with the straight lines in their boundary, right? There are 4 squares you can see and there is one rectangle in the center, right? These are its shapes. They have asked what these shapes are. So we are familiar with the squares and rectangles. But what makes them squares and rectangle? What are their properties, right? So suppose we consider this rectangle ABCD. The points A, B, C, D, they are the corners of the rectangle. Then line AB, BC, CD, DA. They are the sides of the rectangle. And then angle A, let me change the color. So angle, this is angle A, this is angle B, this is angle C, this is angle D. So 4 sides, 4 rectangles, 4 angles in the rectangle. Now if you see here, the opposite sides here, the blue lines. Can you see the blue lines? These 2 are blue lines and these 2 are orange lines. So the blue sides, that is AB and CD, they are called the opposite side as they are lying opposite to each other, right? And similarly we have another, that is AD and BC. They are also opposite sides. Now why the same color is chosen? Because they are equal. Opposite sides are equal. So in a rectangle, the opposite sides are equal in length and all the angles are 90 degree. If you just see here again, all the angles for 90 degree, instead of showing the curve, what we can do is we can show a box. Always make a box for 90 degree. So all angles are 90 degree and opposite sides are equal. So these are the properties of a rectangle. As in the case of rectangles, the corner and the sides are defined for a square in the same manner, right? Now what is the difference here? In square, all sides are equal, not only opposite side. Of course, opposite sides will be equal because all sides are equal. And all angles are 90 degree. Fine? So this is about square. See the rectangle 8.4 and the name given to it, A, B, C, D. This rectangle can also be named in other ways. So I'll go back and I'll just show you the diagram and then I'll just show you what all different names can we give. So if we talk about this rectangle, then we suppose we start with A. So we can write it as A, B, C, D or A, D, C, B. Okay, there are 2 ways. If you start with A, you can go here or you can go in the clock manner, clockwise or anti-clockwise. Suppose you start with B, so B, C, D, A or B, A, D, C. If you start with C, C, D, A, B or C, B, A, D. If you start with D, D, A, B, C or D, C, B, A. So one same rectangle can be named in 8 different ways. 8 different ways. All are correct. Now what care you should take? What is asked over here? These are 8 names which I just explained are given. For one was already given. So can a rectangle be named using any combination of the labels around its corner? No. Like for example, it cannot be named as ABDC or ACBD. Now let us see what is ABDC. What happens over here? If you say ABDC, so you can't do that. Or if you say BCAD, means you can't go diagonally. You have to go in the cyclic order only. That is most important. Okay, you cannot cross and go. So the Whenever you are writing a name, a rectangle is given in the question, so always write them in sequence A, B, C, D or A, B, C, D. That's okay. But you can't write A, B, C, D. That would be wrong. Similarly, you can't name it A, B, D, C or A, B, C, A, D. Okay. So that is most important. You cannot write it that way. You can't take any order. It has to go in a cyclic order. The name has to be in the cyclic order. That's most important. So what names are not allowed? That I just showed you, A, B, D, C or A, C, B, D. Now, which in a valid name, the corners occur in an order of travel around the rectangle starting from any corner, right? So you start from any corner, that's not an issue, but you have to travel along the rectangle, around the rectangle in an order, cyclic order, okay? So here the question is, which of the following is not the name for this square? So we just understood the rule. So let us check one by one. So PQSR, PQSR, right? So I just told you that this should not go in cross. It should be in a cyclic order. So first one is not possible. Then we see SPQR. So this is okay. Then third one is RSPQ. This is also fine. Then QRSP. This is also okay. So which name is not a name for this? So PQRS. PQSR is not a name. PQSR is the answer for this question. Okay. Rotated squares and rectangles. Now here is a piece of paper having all its sides equal in length and all angles is 90 degree, right? You can see this one and this two. So it is rotated as shown in the figure. Is it still a square? So this is a square with all sides equal, all angles 90 degree and this is just rotated. So still is it a square? Yes. Let us check if the rotated paper still satisfies the properties of a square. So are all sides still equal? Yes. Are all angles still 90? Yes. Right. So it is satisfying all the properties of a square. Right. So rotating square does not change its length and angles. Therefore, this rotated figure satisfies both the properties of a square and so it is a square. Now by the same reasoning, a rotated rectangle is still a rectangle, right? Can you see this is still a rectangle? Here what same reasoning you can give? Opposite sides are equal. Opposite sides are equal and all angles are 90 degrees. So this opposite sides are equal and then all angles are 90 degrees. That means it's a rectangle. Right? So if whatever is the orientation, if it satisfies all the properties, then it's a rectangle. Fine. Now the figure it out exercise based on the concept which we just understood. The first question is draw the rectangle and four squares configuration shown in figure 8.3 on a dotted paper. So that's our first question. First I'll show you which is 8.3. So this one, can you see? In the center there is a rectangle and on four sides there are squares. So this we need to draw in a dotted sheet of paper. So now we will do the first question of the figure it out exercise. Draw the rectangle and four squares as we saw. I just showed you the figure 8.3. So first thing is what we do, we draw a rectangle in the center, right? That you can choose of any length. So suppose we take the length as 5. Five dots by 3 dots. So once the rectangle is drawn, now we need to draw 4 squares. Why this arrow is there? 4 squares which should be at symmetrical places. Now symmetrical places means you know what is symmetry. They should have a line symmetry. So suppose I decide to leave one square here and then leave this small square and then draw a square in the corner, in the first corner, right? So similarly, you will have to leave one corner over here and make a square. Okay. Just use scale so that you get straight lines. Here with this, it is little wavy. Similarly, here also, on the left hand side, count this square, leave that square, and then so the figure becomes here also count this and leave one square. So then the figure which you get is a symmetrical figure. Question number 2. Identify if there are any changes in the square in this collection. Use measurements if needed. Right. So what you can do, first we can count, either you use scale, right? So in your book you use a scale and count the length of all the sides, and also with the help of a protractor you can measure what these angles are. So if all sides are equal and all angles are equal means it's a square. And without measurement, here also it is given by looking at it. So it's a dot grid. So we can count square these dots 1, 2, 3, 4, 5. Here also 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So all sides are equal. And if you see here, even there is a 90-degree angle. What happens when there is a 90-degree angle? It should form an L shape like that. So here you can see that a box is formed perfectly well, 90-degree, right? So this first figure is a square. Let us check for the other remaining ones. Now if we see the second one, just see, somewhere the dots are there but it is between some dots. And even the angle, this is less than 90-degree here. And this is a little more than 90-degree. So it is not a square. If you see C, question number C, here you see it is an obtuse angle. It is not a right angle. Just see the angles. If you observe the angles and even the lengths, if you count the dots, they are not exactly on the dots. So again, this is not a square. And this, without doing anything, without measuring, actually you can say that it's a rectangle. It's not a square. Because opposite sides are equal, all sides are of not equal, and though the angles are 90-degree, perfect L is formed, but it is not a square. So only the first one is a square. Now if we see question number 3, draw at least 3 rotated squares and rectangles on a dot grid. Draw them such that their corners are on the dots. Verify if the squares and the rectangles that you have drawn satisfy their respective properties. Now we try to draw rotated square first. Let us see. This is answer number 3. So when you do it on a paper, then it would be you can use a scale and a pencil. So suppose we are taking measurements as 2 centimeter, you will get a square. It should be slanting because we are trying to rotate it, right? Maybe you may take 1, 2, 3 points. Just see to it that they are all aligned. If they are aligned, you will get a perfect squares. Right, so like this you can draw squares. And now if you want to draw rectangles, what you are supposed to, so these are squares. And now we'll draw rectangles. So for rectangles, all sides should need not be equal. So you can take 3 lengthwise and 2 breadthwise. So this is a rotated rectangle. Let us try to draw one more. So maybe we take 4 as a length and 3 as a breadth. So you can draw rotated rectangles like that. So this is answer number 3. So with this we complete the figure it out exercise. We will continue with this chapter in the next video. Thank you.